The very last video I'm going to do is going to be on metallic and non-metallic characters or reactivities. If you just look at these very quick representations of metals, non-metals, and metalloids, I think if one of you at least have color coded the elements based on this coding. But generally speaking, all the metals are towards the left, and then the non-metals on the right, and the metalloids are in the middle. And I guess you can guess that metalloids are elements that have both metallic and non-metallic properties. So the way that we define a metal, or at least metallic characters, is a metal is any element that has a tendency to lose their valence electrons when they react. So when we define things as metal or non-metals, we only look at how they react. We're looking at their chemical properties. The easier it is, and this is comparing the reactivity of a metal, the easier it is for a metal to lose its electron, the more reactive it will be. So if it is very easy for a particular an element to lose an electron, it will be an incredibly reactive metal. It will be a terrible non-metal. You probably wouldn't consider it to be a non-metal at all, but it is a very, very reactive metal. Now, again, this is probably a good idea for you guys to think about this for a second before I show you the answer. But if you think about it, if a metal tends to lose valence electrons, it's not going to want to gain an extra one. So it will definitely have low electronegativity. And if it tends to lose valence electron, it shouldn't take too much energies for that to happen. So it also has low ionization energy. So a metal would have low electronegativity and low ionization energies. And the lower these two values are, the more reactive the metal will be. Which means that the reactivity would decrease across a period, because as you go across a period, the attraction between the nucleus and the valence electrons increase, so that would make it harder to lose an electron. But Dow group reactivity would definitely increase. And I think for the class that I have shown the videos of the reactivities of elements going Dow group 1, you probably can remember this. You need to explain the trend Dow group and across the period. I think this is a very good point to pause the video and actually try to do this question yourself. But I'm going to show you the answer now. So we're pausing. We're doing the question. I'm not going to watch sand for 5 minutes, because literally that's what I'll be doing if I start. Okay, anyway, so again, if you have to explain this question, it's a very good idea to start with the two concepts that determine the attraction between the nucleus and the valence electrons, and that would be core charge and the number of shells. So I guess the first part wouldn't change regardless of what the question is, because you have to bring it back to attractions between the nucleus and the valence electrons anyway. But if you go Dow group, the attraction decreases, making it easier for the valence electrons to leave, and that would increase metal reactivity. Going across a period, the opposite holds true. If you talk about both core charge increasing and the number of shells remain constant, you would definitely have an increase in this attraction between the valence electrons and the nucleus, so metal reactivity would decrease. Okay, I've shown this video for one class. For the other class, this is the YouTube link. I'm not going to watch it. So if you really are interested, just click the link and then you can have a look at the video yourself. It is pretty interesting. I'll probably show it to your class on Monday. I didn't show this video to any class, so I guess you can try to see it yourself. We're just looking at actually no, I think I showed it to one class. Once again, this is the reactivity of metal elements in group 2 going down a group. So hopefully you can see the metallic characters increasing. Now the opposite of that also is going to be non-metallic characters, and it is literally the opposite of metal, as in they are elements which have a tendency to gain electrons. So they will, the easier it is for them to attract or share electrons, the more reactive they are, which means that the reactivity of nonmetals would be the exact opposite of the reactivities of metals. The reactivity would decrease Dow group and increase across a period. Same time, I probably have to make a note here, except for the noble gases, which would not like to lose again electrons, period. They do react very, very slightly though. I wouldn't say they don't react at all. I remember an article being sent to me a few years ago about the very, very small reactions of noble gases. But for the most part, you wouldn't classify it to be a nonmetal, and definitely its reactivity is not going to be higher than the halogens, which is the group right before it. And lastly, metalloids exhibit both metallic and nonmetallic characteristics. We're not going to talk about metalloids too much, but I have semiconductors here, and I have silicon, which is an example of metalloids. I think that's the end. Congratulations, we have finished this topic. Yes, I'm going to keep those annotations.